Welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra. I'm your host, Mr. Takeda, and I am going to teach you some algebra. This is lesson 4.4 from the Big Ideas textbook, just the general ideas of our flipped classroom on scattered plots and lines of fit, in which we ask the essential question: how can you use a scatter plot and a line of fit to make conclusions about data? Okay, that last part here about data, well, that's going to be kind of our important idea um, in this section, is that now we're going to think about data and what we know about math in order to inform our ideas of data. Okay, so this is, I think, a fairly straightforward and simple lesson today. It gets, well, we'll see. So first we start with some vocabulary: scatter plot. Now, scatter plot is a graph that shows the relationship between two sets of data, and they're graphed as ordered pairs in the coordinate plane. So previously we had worked on functions, which are lines, because we have that mathematical relationship. This is not as neatly done, okay, because in real life, math is a little messier. You have to think mathematically, but the nice relationships aren't always there. So these are ordered pairs. So think of these as data points, or as points on the coordinate plane. But scatter plots can show trends in the data, and that's what we're looking for today: trends in the data, and we'll talk about that in a little bit. Okay, so I'm given here a scatter plot. And this scatter plot shows the amounts x in grams of sugar, that's our independent variable, and the amount of calories, which is on our y-axis, in 10 different smoothies. So we can look at this, and from this we can answer some questions. How many calories are in the smoothie that contains 56 grams of sugar? Well, down here, 56 would be between 54 and 58. So I go up, and there's only one, and it's right here. This is our point right here. So 270, and this is calories. Okay, so we're gaining some information from the data on the scatter plot. Question B: how many grams of sugar are in the smoothie that contains 320 calories? Okay, so it works the other way as well. Calories this way, 320 calories. There's only one. It's this one here. How many grams of sugar? Down here to 70 grams. The question C, what tends to happen to the number of calories as the number of grams of sugar increases? Okay, so our number of grams of sugar increases this way on the graph. Our calories increase this way. So as the sugar increases, so down here we have little sugar, lower calories. Up here we have medium amounts of sugar, medium calories. And up here we have a lot of sugar and a lot of calories, the most calories. So what tends to happen to the number of calories as the number of grams of sugar increases? Well, sure. The number of calories increase as the number of grams of sugar increase. Yeah, there we go. The number of calories increase as the grams of sugar increase. So I want to just point out some language here. Look how I answered the question. The question is, what tends to happen to the number of calories? So we're asked that the question is, what's happening to the number of calories as the number of grams increases? So then my answer says the number of calories increase. So now I'm referring right back to that in order to have clear communication here. The number of calories, what happens to them? They increase. As what? As the grams of sugar increase. Okay, so make sure you have clear explanations on these things. Let's take a look at the next example here. The next one, we're talking about correlation. We can have positive, negative, or no correlation. This first graph here, can we answer that question? What happens? Okay, we have number of vehicles owned and a person's age in years, and when this is our scatter plot. Can we answer the question, what happens to the number of vehicles owned as a person's age increases? So do we see a pattern? Do we see a trend in the data here as the person's age increases? We really don't. I mean, sometimes a young person can own 4 cars, and an older person up here in their 50s can own 4 cars, and this person owns less. This older person owns less than this younger person. So there's really no correlation here. There's no correlation between a person's age and the number of cars they own. Now for this one, the question, we have average daily temperature and then coats sold per day at a store, okay? So the question is, what happens to the number of coats sold per day as the temperature increases? Well, the coats sold per day decrease. Right? So when it's cold, they sell a lot of coats, and when it's warmer, they sell less coats. These are less coats. So we can say that the coats sold per day decrease as the average daily temperature increases. So what happens here, since this number is decreasing as this number increases, this is what we call a negative correlation. A negative correlation. And there you go. And again, so the dependent variable, the y values, decrease as the independent increase. And if we go back and look at the previous example, this is a positive correlation. The calories increase as grams of sugar increase. The y variable increases as the x variable increases. This is a positive correlation. Okay. You can also think of them as like slopes. This would be like a negative slope. If we had a line that goes through, then we'll talk about lines in a second. And this one would be like a positive slope if we had a line going this direction. Positive correlation, negative correlation. Okay. Get this down in your notes. This is using a line fit to model data. So after you do the scatter plot, and then you can decide what's going to be modeled by a line. So you're looking for a correlation here. Now, this really step 3 and step 4 that we're looking for here. This is kind of the new part. Draw a line. This is a straight line that appears to fit the data closely. There should be approximately as many points above the line as below it. And write an equation using 2 points on the line. So what we know about writing equations using point slope form, that's what you're going to do. The points do not have to represent actual data points. So your line doesn't have to go through data points. You're going to use points that are on the line to write your equation of the line. Okay, so let's take a look here. Get this in your notes. Pause this if you need to, and we'll take a look at an example. So here we have this table. This is the table shows the weekly sales of a DVD and the number of weeks since its release. Write an equation that models the DVD sales as a function of the number of weeks since its release, and then interpret the slope and y-intercept of the fit. So the first thing we need to do here is plot this data. We're not going to have a nice linear function here, even though we're going to try to write a function for this, because you'll notice that 19 to, these are all even, 1, 2, 3, 4, 5, but 19 to 15, that's a drop of 4, then a drop of 2, a drop of 2, a drop of 1, a drop of 2. So this is not an arithmetic sequence. It is not a linear relationship here. So using the Desmos calculator, we can model this. And here we go. Now, Desmos graphing calculator lets us put in a table like this, and it'll produce a scatter plot. Now, to do this, where you'll come up to where it says Add Item, and you click there, and you can add a table. And once you add the table, then you can just fill in your X and Y values and you get this nice scatter plot here. Now, since I can't draw on this to show you the line, what I'm going to do, I've actually done this, I've already pre-prepared this. I'm going to go back to the other software and we'll put a line on it and see what we get. Okay, but that's how you're going to create a table and a scatter plot using your Desmos graphing calculator. Pretty easy. Again, under the plus add item, add your data table, and put in your data, and it draws it for you. Okay, so there's our data. Here's a copy of my graph, and what I want to do now is I'm going to create a line. Now this is just an approximate line right now. I'm going to move it around to see. Now, if I look at this, I see too many data points under it, not enough above it, so I'm going to kind of adjust it maybe this way. What would be nice to do if I can get this to go through 2 data points? I'm going through 2. I have 1, 2, 3, 4 above it, and 1 above it, but the one above it is kind of high. I can adjust it, maybe something like that. I have 2 above it. I've got 3 above it. I've got 1, 2, 3 above it, 3 below it, and it's going through 2. So I'm going to keep these here. Again, I have 1, 2, 3 above. I have 1, 2, 3 below, and it's going through 2. So this point here is what, 510. This point here, you can't really. I don't know if you can see this on your screen. It's 6, 8. On mine, I have a graph, but by the time I run this through the video processing, sometimes it gets a little worse. Okay, so now I'm going to calculate slope. So 10 minus 8 over 5 minus 6. 10 minus 8 is 2. 5 minus 6 is negative 1. So I have a slope of negative 2. And then it looks like I really don't know if my y-intercept is up here. Well, I can use point slope for this. So y minus, I'll use 10 and 5, I guess, or I'll use 8 and 6. Y minus 8 equals negative 2 times x minus 6. Y minus 8 equals negative 2x plus 12. And if I add 8 to 12, I get 20. So even though it doesn't look like I'm going through 20 here, maybe if I, and that's the thing about these lines of fit here, they're all going to vary a little bit based on how you draw your line of fit. We have a better way to do this using the calculators, and we'll get in. Hopefully, we get into that soon, using the calculators to do a better job finding these lines of best fit for us. But that's the line of best fit, and that's it for now, mister. That's it for now, mister. And I'll see you in class next time. Thanks a lot. Have a great rest of your day.